All right, so what we're going to do is, without a calculator and using our special right triangles, we are going to calculate sine of 300 degrees as well as cosine of 225 degrees. So in order to do this, what we're going to do is we're going to start from our special right triangles inside of the unit circle. So let's assume these are perfect unit circles, even though obviously they are not. All right, perfect unit circles. And if I want to do sine of 300 degrees, well, then I'm going to have to go 300 degrees, which is going to put me to about here. I'll just show you with an arrow how I got to there. So I'm going to start from quadrant 1 on the x-axis always, and if I went 300 degrees, I imagine that I could end up about there, which would leave me with a reference angle of 60 degrees. So that means that I'm dealing with a 30, 60, 90 triangle. More than that, it is a 30, 60, 90 right triangle that has a hypotenuse of 1. Because remember, this is the unit circle. We just established that. And the reason we did that is because we know that sine of an angle is equal to our y-coordinate, and cosine of an angle is equal to our x-coordinate, and tangent of an angle is equal to our y-coordinate divided by our x-coordinate. But this is only true if we operate within the unit circle. So what are the coordinates of that point on the unit circle? Well, this is a special right triangle. It's a 30, 60, 90. And I've adjusted it so that the hypotenuse is 1. So that means that this side has a length of 1/2, and this side has a length of radical 3 over 2. So that makes this the point 1/2 negative radical 3 over 2. Because remember, if this is a point, then this distance would have to be a negative. If you want to remember that by making this negative in the first place, you can. So then if I want to find sine of 300 degrees, all I need is my y-coordinate at that point. It's just radical 3 over 2. Negative radical 3 over 2. I don't have to do any calculation at all. All I've done is drawn my special right triangle. I know that those are my side lengths because we've done a lot of work around adjusting our 30, 60, 90 and our 45, 45, 90 triangle so that they fit inside of this unit circle. And now I'm just going to keep using the point that's on the edge of this unit circle to evaluate sine, cosine, and tangent. We'll do the same thing with cosine over here. Cosine of 225 degrees. 225 degrees would put me about here. So I'm going to draw my right triangle that would result from a 225 degree angle. So that is 225 degrees, leaving me with a 45 degree reference angle. So I'm just going to indicate that this is a 45 degree angle by showing that these two angles are congruent. And if that's true and that's a 90 degree angle, then this must be a 45, 45, 90. I know that because I'm in the unit circle that that's a length of 1. So we have adjusted the sides of our usual 45, 45, 90 triangle to now have these lengths if we're operating within the unit circle, which we are in this case. So that would make this point right here that is on the unit circle the point negative radical 2 over 2, negative radical 2 over 2. So if I'm using cosine, all I need is my x-coordinate at that point. My x-coordinate is negative radical 2 over 2, so that must be cosine of 225.